Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to discuss one example of a projectile motion. In this example, a football is kicked at a ground level with speed 18 meter per second at an angle 35 degree to the horizontal. How much later does it hit the ground? The question wants us to find the time of flight of the ball, or in other words, the time taken for the ball to hit the ground. This example may seem difficult because the only given value is the velocity and an angle in which the ball is kicked. However, we can solve this problem easily if we follow the steps of the problem solving as discussed in the previous video. Let's start by drawing the diagram of the problem. When the ball is kicked with an initial velocity at an angle, the ball will follow a parabolic path. This path is called a projectile motion. Can you label the diagram with information provided in the questions? There are two obvious information given in the questions. The first one is the initial velocity and the angle theta. The initial velocity u is given by 18 meter per second, while the ball is kicked at an angle 35 degree from the horizontal. Because projectile motion is a two-dimensional motion that involves a horizontal component and the vertical component, it is good if we can label the horizontal and vertical component of the velocity. In this diagram, we can label the y component of the initial velocity as well as the x component of the initial velocity. At the end of the motion, the ball will move with velocity v. The value of v is unknown, and the velocity of v can also be labeled in terms of x component and y component, vy and vx. If we take this point as the origin, therefore we define the time at the origin as 0 second, while we want to find the time when the ball reached the ground at this point. That time is unknown. After we draw this diagram with all the labels and the coordinate axes x and y, we should list the known value to make our life easier. Let's identify the known value given in the questions. In these questions, the known value is the initial velocity u, which is 18 meter per second, and angle theta, which is equals to 35 degree. That is given in the questions. However, there is a hidden information that is very important to solve this problem. The first hidden information is the displacement in the vertical component. If we notice, the ball is actually reached the level ground after being kicked by the player. In other words, the vertical component of the ball is 0 meter because it returns to its original height. The second hidden information is that the velocity in y component just before the ball hits the ground is actually equals to the negative initial velocity in the y component. This relation is true because the ball returns to its original height. From the diagram, we can see that the magnitude of the speed is equal, but Vy is downward instead of upwards. Another known value that is actually given in the list of constant is actually the gravitational acceleration g, which is equals to 9.81 meter per second square. Now we have done with the known value. Next, let's identify the unknowns. We need to identify the unknowns to make sure we know what the question wants and we know what we want to solve the problems. Let's identify the unknown value first. The unknown value in this question is obviously the time in which the ball hits the ground. In fact, this is what we want to find. In order to find this, we might need to know the value of vertical component of initial velocity or the horizontal component of initial velocity. Another unknown value in this problem is the range or the horizontal displacement of the ball. Now, by going through the known and unknown values, could you identify the suitable equation to solve the problem? By looking at the known and unknowns value, we know that we cannot use the equation in x component. The reason is because the equation in x component is just as x is equals to ux times t. Both time and the horizontal displacement is unknown. Therefore, we cannot use this equation. What left is the equation for the y component. In y component, we have the equation for displacement as y is equals to uyt minus half gt square and vy is equals to uy minus gt. If we notice, from the first equation, we have all the value except time t. While the second equation, we know the relation between vy and uy, and therefore we can find and solve the problem for value t. The value of uy can be easily calculated by using trigonometric equation uy is equals to u sine theta. So now we have two equations that can be used to solve the problem. From equation 1, if we use sy is equals to uyt minus half gt square, we can substitute the value for sy. 0 is equals to u sine theta is equals to 18 sine 35 times t minus half gt square. and G is given by 9.81 meter per second square. By using your calculator, solve this equation for the value of t. The value of t obtained from this equation is 2.11 second. This is the solution if we use equation 1. Another equation is Vy is equals to Uy minus Gt. We know that the relationship between Vy and Uy is Vy is equals to negative Uy. That is equals to Uy minus Gt. We can simplify this equation. We have negative 2 Uy is equals to negative Gt. Therefore, t is equals to 2 Uy over g, and Uy is equals to 18 sine 35 divided by 9.81 meter per second square. Use your calculator to solve for the value of t. We will get the same answer as solution number 1, which is equals to 2.11 second. That's all for this video. Thank you for watching.